better memorizing it if they just do it over and over and over and over again. So if you want extra copies, I got plenty of extra copies, and if this is not enough, I can run them. But what we're going to do is we are going to derive the unit circle, and you're going to see why we did all those special triangles that we did before we left for spring break. I'll pull those out. You don't have to do all this work every single time. I'd just like you to see where these values come from and why we use them. At the end of the day, what you have to do is memorize all the blanks that are on here. Y'all ready? So everything. Oh, yeah, what you mean? Let me see. Oh, actually, which one are you looking at? Which one's staying on the back? 8. X, 60 degrees, Y, 10 root 3 over 3. Is this one you're talking about for 8? Or am I on the right sheet? Okay. Huh? No. Wait, let me see it. Look out the window at the wall. Yeah. All right. This is a 30, 60, 90 triangle, so I'm going to always make my way back to the short leg. How do I determine which one's the short leg? 8. The one across from the 30-degree angle, so this is my short leg. Everything's based on the short leg. So to go from short leg to long leg, I multiply by what? Close. Square root of 3. So if I take this, if I do 10 root 3 over 3 and multiply by the square root of 3, I end up with 10 times 3 over 3, which is 10. And then to get to the hypotenuse, I just take the short leg and times it by 2. So this would be 20 root 3 over 3. Oh, you're right. To get the what? To get the hypotenuse. What? You double the short leg. Uh-huh. You always make your way back to the short leg, and then you work from there. That make sense? 45, 45, 90. You go from these legs, then you multiply by the square root of 2. What's the difference? Yes, 30, 60, 90. Which other one did y'all say can you come up? 10? 9 and 10. Number 9, I have a, here you go, Noah. This is a 45, 45, 90 triangle. This is 6 square root of 2, so I've got the hypotenuse. I need to make my way back to the leg, so instead of multiplying, I'm going to divide, and I'm dividing by square root 2, so it's just 6. The back, okay. Yeah. 14 and 18. All right, 14 looks like this. 14, I have a 45, 45, 90 with the hypotenuse. And then it looks like on it I have a 36, 90. All right, so there's what's given. I'm going to start with the 45, 45, 90, and I'm going to back it up to find the leg. So I'm going to divide by what? Square root 2. So if I take 5 and I divide by square root of 2, what I really have is 5 square root of 2 over 2. Okay? So that's this one, but it's also this one because the legs are the same because it's a 45, 45, 90. Now, I'm going to look at my 30, 60, 90 triangle, and remember, I'm always making my way back to the short leg. So what's the relationship between the hypotenuse and the short leg? It's doubled. That's exactly right. If I've got a regular 30, 60, 90 triangle, whatever this is, it's doubled to give me the leg here. And here it's times square root of 3. So I'm going backwards. I'm going from hypotenuse to short leg, so I need to divide by 2. So that means that this is 5 square root of 2. And now how do I get from short leg to long leg? Times the square root of 3, right? So 5 root 2 times square root of 3, which would be 5 square root of 6. Yeah? Yeah? That came from, I took the short leg and multiplied by square root of 3. Well, you're probably going to get your project tomorrow. It's not this week. Good. Who told you you weren't? I think it's because we have a new principal. She's not really saying a whole lot about much. Yeah. So Miss Wallace always did that. She's not here this year. We've got a new principal. I don't really know. All right, I'm going to go with the 45, 45, 90. I know that this leg is 5 because I know that the legs are the same. And now how do I get from leg to hypotenuse on 45, 45, 90? Close. Square root of 2. Now I need to get back to my short leg, which is here. I've got the hypotenuse. So what am I going to do? Square root of 2. No. 2. You were right the first time, 2. Because 30, 60, 90, it's doubled. Yes. So to get from hypotenuse to short leg, I divide it by 2. So 5 root 2 over 2. Now how do I get from short leg times it by the square root of 3? So this will be 5 square root 6. Yes. Didn't hit it hard enough, and they've struggled with it in calculus. And not that they've struggled with it, but there's so much, because calculus, the AP exam is timed, and so a lot of things are non-calculators that you just have to know, and units have those one of those things. And so they said, had we known it better in pre-cal, then because they just kind of memorized it and didn't, we did it one time and that was it, and then moved on. So maybe May 13th. 13th. Ready? Yeah. Don't be scared. Yeah. Yeah. And. All right. Here's my circle, my nice mush circle, but nonetheless. If you notice on your sheet, there are 3 triangles kind of dashed out here. This is just so you can kind of wrap your brain around where these values and numbers are coming from. Remember when we were talking about theta and the degrees of theta and how it starts at the x-axis and then it measures up? You know what I'm talking about? And so if I went from here to here, that angle would be 90 degrees. Straight across 180, right? And if I clicked around again, what would this be? 270. And then that's right. So 0 degrees or 360. Well, these are all parts that, yeah, these are all there. So if you notice, there's several different parts on your circle, right? There's a little thing with a degree sign. That's your degrees. That's what I'm writing here. Then there's radians. We're going to convert it over to radians in just a second, but not quite yet. And then there's some coordinates there, and we're going to fill all those in the standard value short. All right, but now that you understand kind of how this is clicking around, we have, and I'm just going to work in quadrant 1, because if you can get quadrant 1, the rest of it's a piece of cake. The top right. All right, y'all ready? So I can derive these 3 triangles within quadrant 1. And you'll see why in just a minute. If I drop down from here at 90 degrees, it makes this right triangle, right? And this is going to be 30 degrees. And I'm actually going to click 30 degrees, 45 degrees. So this would be 30 degrees, 45 degrees. And then your last one there, 60 degrees. That's exactly right. And so I've got these 3 special right triangles is what I've got. Now, we call this the unit circle. And the reason we call it the unit circle is the radius of the circle is 1 unit. Okay? What does that mean? That means from the center of the circle to any point on the outside of the circle, it's 1. Okay? So I'm going to kind of pull this triangle out here so we can look at it a little bit. I'm going to do this 30-degree one first. I've got this. This is this first one here. And this is 30 degrees. Now, if the unit circle has a radius of 1, that means my hypotenuse is 1. Agreed? It's up to you. You won't ever have to draw it again. I just like you to see where it is. Now, based on that, I could find the other missing sides of the triangle. Do you agree? I've got the hypotenuse. I'm going to make my way back to short leg. How do I do that? Divide by 2. So this leg is a half. And now I take this short leg and do what to find the long leg? Square root of 3. That's exactly right, right? So I got square root of 3 over 2. Anybody confused about that? This is always 1 because the unit circle has a radius of 1. So your hypotenuse on all these triangles is 1. It's kind of your given. Because to go from hypotenuse to short leg, we'll go back to this. To go from hypotenuse to short leg, I had to divide by 2. That's radians. Yeah. All right. Can we all see where those 2 sides came from? Okay, now think in terms of a coordinate plane, right? If I want the coordinates of this point, how far over did I go? Think about this triangle being imposed right here on the circle. How far over did I go? Okay, square root of 3 over 2 is how far I went over. And how far did I go up? Because that's my y coordinate. A half. Yep, that's for the 30. Yep. Now, while I'm here, let me go ahead and put this in radians also, because you've got a space for radians there. If the degrees are 30, what would the radians be? How do I go from degrees to radians? Pi over close. Pi over 180, right? I take the degrees and I multiply by pi over 180. And so what? So you need to calculate it. What did you say? Pi over 6. That's your radians. You've got a spot there for your radians. So degrees, and I'm in a little bit different order than yours are in, but it doesn't matter. All right, so at 30 degrees, I'm at the coordinate root 3 over 2, 1/2, and my radian degrees are pi over 6. Okay? All right, let's move on to the next one. Remember, if we can get this very first quadrant worked out, the rest will follow, no problem. All right, we're going to get to that. All right, let's look at the 45, 45, 90 triangle. I guess let's do the radians first. What's 45? We'll come back to tan. How'd you do that so fast? You're right. All right, I'm in a 45, 45, 90 triangle, and I'm given the hypotenuse. How do I make my way back to 11? Divide square root of 2. Square root of 2. So if I do 1 divided by square root of 2, I end up with square root of 2 over 2. Right? Because I rationalized that bottom. So this is square root of 2 over 2, but that means this is also square root of 2 over 2. So it goes over the same amount it goes up. So the coordinates here, square root of 2 over 2, square root of 2 over 2. Remember, I just have to get this first quadrant derived, and the rest will follow. All right, 60 degrees. In radians, what do I have? Pi over 3. Now my coordinates are going to be a little bit different because my angle has moved some, right? Instead of this bottom being the 30 degrees, it's the 60 degree now, right? Hypotenuse is still 1, but how do I make my way back to the short leg? Square root of 3, right? The same way I did here, but the difference is, actually divide by, what'd you say? How do I make my way from the hypotenuse to the short leg? Divide by 2. The short leg, which is down here now, is a half. You're really just flipping these coordinates. So you see it's really not that bad as far as say that again? Yes, yes. So it's 1/2 root 3 over 2. Yeah. So to go from hypotenuse to short leg, I would divide by 2, which is what I did. Right. Yes, yes. Because this is my short leg here. This is my short leg here. They've swapped places. Okay, so what do you do for 90? Remember, the whole point in the triangles is finding out the length of the sides, right? But for this one, I really don't need because I know what the radius of the circle is. What's the radius of the circle? 1. So what this in radians is going to be pi over 2. But what are the coordinates here of this point? 0, 1. Because the radius is always 1. Okay? All right. Before we get to tan, let's do the rest of the circle, and then we'll do tan. Say again. 1. Radius is always 1 on a unit. Yep, at 90 degrees. So we're just looking, it just goes up. Oh, radians, pi over 2, I'm sorry. 90 times pi over 180. All right, now the beauty of the circle is it's symmetric because it's a circle. So I've got these 3 points that coordinate all the way around, right? The only thing you have to remember here, now you're going to have to remember the degrees and the radians and how those correspond, but your coordinates are going to be the same. It's just sometimes they're going to be negative and sometimes positive. Let me show you what. All right, if there's 30 degrees from here to here, then there's 30 degrees from here to here. So what are my degrees here? 120, right? You see what I'm saying? The circle is, even though my picture's not perfectly symmetrical. Okay, so to go from this point to this point is 30 degrees. So it's going to be another 30 this way because it's symmetric, right? So this is 120 degrees. Now I can convert that over to radians. Well, this one is 60, so you start at 60. 30 and 30 would be, yeah, so 120. How about in radians? What's 120 divided by 180? Because I'm doing times pi over 180. So 2 pi over 3. And now let's look at the coordinates, right? This coordinate is teaming up with this coordinate, but I just need to change the negatives and the positives, right? So this one went to the right a half, so this one's going to the left a half. So negative 1/2 square root of 3 over 2, because I'm still going up, right? Because if you think about it here, x is negative, but y is positive. Here, in first quadrant, it's easy because everybody's positive. What do you think the next degree is? 135. How did you figure that out? Because there's 15 in between these two, right? It goes 30, and then it adds 15, it adds 15, and it adds 30. So I'm going to do the same over here. I'm going to add 30, 15, 15, and 30. I'll do that each time. So this is 135, which means this one's going to be, yep, 3 pi over 4. And at 150, what is it? And I'll go ahead and put, we know this to be pi over. Let's do the coordinates here. The over 4s are the easiest, the ones in the middle. They're always something over 4, and they always have the same coordinates. You just have to decide which one's negative and which one's positive. So what are the coordinates at 135? Uh-huh. They have no Dorito on them. All right, what do you think the coordinates are of that last point? All right, what'd you get for the coordinates here? We didn't continue. Okay. Uh-huh. That's right. You see how we're using the first quadrant to fill in the rest? Once you get the first quadrant, it's really not bad. I hope y'all understand this. Really not bad. It does. It does. Wait until we start using it. Are we doing that today? I'm going to show you how to use it. Find the tangents. It's not bad, though. It's just, once you get this, when you have this in your hand, it's just copying off of that. You'll see what I'm talking about. All right, let's do quadrant 3. Tell me what happens in quadrant 3 with x and y. Oh, sorry. What did you tell me? Close. This is 0, 0, negative 1, 0. Oh, sorry. 1, 0. 0 is the radians. 0 radians. 0 degrees, 0 radians. Yeah. All right, quadrant 3. X is negative, y is also negative. A negative, negative. Yeah, it helps me if I write that on there. It helps me remember. All right, 1, 2, and 3. That's why I told you if you want some blank copies to help you, I got plenty of those, and I'll run some more. All right. What do you think the degree is here? What are the radians there? That's correct. Yes, yeah. Do it divided by 180, math in or inner. Yep, yep. Now, right now, that's what we're doing to derive it. As you get more and more familiar with the unit circle, you'll need to just remember what those values are as you go, and you'll see. Yes, yep. So what are the coordinates of this one? And you got to look at how far over you're going, which one it goes with. So what are the coordinates here? Yep. There you go. I know what you meant. Negative root 3 over 2, negative 1/2. Well, so the ones, this one, and then the one closest here are the ones that go together. Okay? And if you think about it, you're going over further than you're going up, and root 3 over 2 is bigger than 1/2. That's the way I think through it. And then this one, this one, this one, and this one are the ones that go together as far as coordinates go. All right, how about the next one? What's the degree? 225. There you go. Notice these are all over 4 when they're in the middle. That will help you memorize them. What are the coordinates? Perfect. Oh, we're getting this. Look at you go. How about the next one? What are the degrees? Oh, wait. Okay. No, only the ones in the middle are the ones that are over 4. What did you get for this one? How about the coordinates here? Is it as bad as you thought it was going to be? Yeah. You had no expectations. It's not as bad as the rest. Wait, so when we do our project. Yes, yes, yes. Yeah. So no. You're gonna find the angles accurately, like you'll use a protractor to find the 30, 60, 90 and all, but past that, it's really just practicing with it is. It is. It's just an opportunity to give you a project. So. Huh? Yeah. Yeah. Second time was definitely easier than the first one was. All right, how about at the bottom here? What are my... Yep. Yep. Last quadrant. This one, X is positive, Y is negative. The radius is always 1. So going straight down and it's on the circle, that means it's 1. All right, give me the degrees on this next one. 300. What is that in radians? Nice. How about the coordinates? That's exactly right. Okay, you are eating this up. So okay? Yeah. Okay, you okay? 315. How about in radians? Last one, 330. But in radians, there you go. Well, yeah, 360. We'll wrap around 360. Coordinates here would be root 3 over 2. And we said we'd wrap back around to 360. That's the easy one because coming back away around this way, remember how many radians are in a whole circle? 2, 5. From this way it's 0, but if you loop all the way around and back up here, it's 2 pi. Yes, and the coordinates respectively. Yep. Yep. 1, 0. All right. Now, before I show you tangent, look at this beautiful circle. Isn't it gorgeous? What's the radius for 0? 0. All right. I'm not redoing. They can watch the video. But at the end of the day, you don't have to know how to derive it. You just have to memorize. Yeah. All right. Now, how are we going to use it? Yeah. I want you to take your calculators just a second and make sure you're in radians just for a minute. So hit mode. Change it to radians real quick. Now, as you go around your unit circle, and this only works on the unit circle, right? Each point has a coordinate that goes with it. Agreed? The coordinate here is the cosine of that angle, and the y is the sine of that angle. And let me show you what I'm talking about. Let's take, for instance, let's go at 30 degrees, which is pi over 6. And I'm going to do one that's going to come out nice and neat on your calculation. I want you to do the sine of pi over 6 on your calculator and tell me what you get. The second, yeah, carry under clear. 0.5. 0.5, which is what? Ask me again, Kate. Hit mode and make sure radians is highlighted. 0.5. And look at the coordinates right here. At pi over 6, the y, which is sine, is 1/2. Right? This is a way to find these values quick. So if I ask you, what is the cosine of 7 pi over 4, what would you tell me? Out your calculator. Yes, that's right, Abby. Positive this time. Cosine's your first one. Okay, so I always remember it because x and y, x comes before y, c comes before s. This is 7 pi over 4, so the cosine, I would take the x value. What about the sine of pi over 3? That's exactly right. Does everybody see how we're using the unit circle to answer these questions?
Where's the 2 pi over 3?
2 pi over 3 is up here in quadrant 2. What if I asked you the cosecant of pi over 4? What's cosecant mean? Because that's what we need to remember first.
It's the inverse. Inverse?
Close. You're right, but what are you doing? Tell me what you're doing. So cosecant is the flip of sine. So this is 1 over sine of pi over 4. So I'm just flipping sine of pi over 4. So instead of square root of 2 over 2, it would be, right? Which I would then rationalize. Okay, so cosecant flips sine. Secant flips cosine. Cotangent, yes, cotangent flips tangent, but we need to talk about tangent real quick. Cosine. Sorry. You have a spot on your circle for tangent because I've got, for all of these, I've got the sine and cosine, I don't have the tangent, so I'm going to show you how to figure it out really quickly. Again, if we can just figure it out for quadrant 1, then we'll have it for all the other quadrants because it is symmetric. The tangent is sine over cosine. And because I'm talking about coordinates, remember, this is my y value over my x value. So since I'm dealing with fractions, we're going to think about multiplying by reciprocals instead of dividing. So let's look at this very first point here, pi over 6. The tangent value at pi over 6 is going to be the y coordinate, 1/2. Instead of dividing by the x, I'm going to multiply by the reciprocal. So I end up with 2 over 2 root 3. Well, so no. So I would multiply top and bottom by root 3 and get root 3 over 3. And you, again, I'm showing you how to find these if you don't remember them, but you can just memorize this circle and you can just say, okay, I know that the tangent here is root 3 over 3. Yeah. All right, so if I've got, it is, and sine is y. All right, so if I do tangent pi over 6, right, that's y, which is 1/2, divided by square root of 3 over 2. I don't divide fractions by fractions. Instead, I do the top times, and I flip the bottom over. Right? Yep. So I got 2 over 2 root 3. The 2's cancel, so I just have 1 over square root of 3, but I can't leave a radical in the bottom, so I multiply the top and the bottom by square root. So what happens at 45? What do you notice about 45? That's right. It's just 1 because the values are the same. So my tangent here is 1. Because those x and y coordinates are exactly the same, if you divide anything by itself, it's 1. Now the tangent at pi over 3 is going to be a little bit different. It's square root of 3 over 2 divided by 1/2, which is times which is what? Right. I have derived my first quadrant, so I am good to use that for the rest of my circle. And let me show you how I'm going to do that. Let's do the 0 and the 90. Let's do the 0 and the 90 because funny things do happen here. At 0, if I do 0 divided by 1, what do I get? It's just 0. But what happens when I click up to 90 degrees? It's undefined. Why is it undefined? Because it's just a straight line down. But what makes tangent undefined there? Divided by 0. I can never divide by 0. So my tangent is undefined. You will see when we graph these here really soon, there's an asymptote there at pi over 2. Because tangent can never be pi over 2. Okay? Now I'm going to use these, and I'm just going to come over here to the rest of my little circle. Okay. What's the tangent at 2 pi over 3? Uh-huh. That's right. How about at 3 pi over 4? Okay. How about at 5 pi over 6? How about at pi? Close, but look at the next one. You've got 2 negatives divided by each other. So they're positive. So I will sometimes come on my circle, and instead of the x's and the y's here, I'll say cosine is negative, sine is positive, because that tells me that tangent is always going to be negative. Right? So cosine, sine, which here means that tangent is positive. So here, what is the answer? You could. You absolutely could. Diagonally across from it. So this one is going to be root 3 over 3. 1 and square root of 3. Yep. Undefined also. And now on my very last quadrant, my tangent is negative because I have 1 negative and 1 positive. So what's my tangent value here at 5 pi over 3? Uh-huh. Square root of 3. Negative square root of 3. It is. And then -1, and then here's my negative root 3. So should you get confused, you can always find it by doing y divided by x. Or you can just memorize. If you memorize that first quadrant, everything else is so easy to follow. Yes. What do you think about the unit circle? What's the sign of 135? I'm just giving you some random. What's the cosine of negative 45 degrees? The cosine. There's not, what do you do to do negative? Go the other way. So go this way 45 degrees. What's the cosine of negative 45 degrees? 32 over 2. So instead of going counterclockwise, it's clockwise. Cosine is the x, sine is the y. So you just use the circle. You don't even use your calculator once you got your circle. Mm-hmm. Yep. So negative 45 degrees, I'm starting at 0 and I'm going this way 45 degrees. I end up at this point. So the cosine of negative 45 degrees is square root of 2 over 2. How about the cosine of 3 pi over 2? Close. 3 pi over 2. Cosine. And that's it.
3 pi over 2 is
So think about it, as you click around, you're at 0, half a pi is up top, a whole pi, and then 1.5 pi. So 3 pi over 2 is 5. So it's 0. How about the tangent of 7 pi over 6? That's right. Yes?